Hello guys, welcome again for another installment. I'm a little under the weather. I don't know if you can hear. No, that's not a fart. In case you heard rumbling noise, that's the chair that I'm sitting on. I'm here at school and the chair squeaks. All right, let's go ahead and get started. The number one, it wants the first derivative. This quiz A derivative is 2. It wants the derivative of g of x. So we're going to use quotient rule. So here we go. I'm going to write g prime of x equals bottom times the root of the top minus top times the root of the bottom all over bottom squared. And then what you do, notice that answer is not in there. So you're going to have to FOIL guys here. So here we go. G prime of x equals 9x squared times x squared. That's 9x to the 4th. Then x squared times 6. That's plus 6x squared. 9 times 5. That's 45. X squared. And finally, 5 times 6. That's 30. And then minus, let's see. 2 times 3, that's 6x to the 4th plus 12x squared all over bottom squared. So again, distributing this negative here, so we get 9x to the 4th minus 6x to the 4th, so that's going to give me 3x to the 4th, and then I see 45 plus 6, that's 51, but then I'm going to subtract 12. So 51, 41, 40, 39. So that's 39x squared. And finally that 30. All over. And there it is. Cool, guys? Alright, let's keep going. Find the derivative of the function. We're going to have to use product rule for these two like so. And then just regular power rule here. So f prime of x first times the root of the second. Negative sine x plus second cosine x times the root of the first 8x plus 9. So let's rearrange it. Negative 4x squared sine x plus 8x cosine x plus 9. And there it is right there. Awesome. Let's keep going. This means second derivative. So you're going to have to take the derivative twice, guys. So d dx of 2 cosecant x is, let's see, negative 2 cosecant x cotangent x. And now that I have that, I'm going to group them. You can choose to have the negative 2 factored out. I'm going to go ahead and pair with the negative cosecant x. So I'm going to take the derivative again. So d dx of negative 2 cosecant x cotangent x. As I stated before, that's going to be my first, that's going to be my second. First times root of the second. The derivative of cotangent x is a negative cosecant squared plus second times the root of the first. And the derivative of negative 2 cosecant x is 2 cosecant x cotangent x. The reason it's positive is because it was already negative, and negative times a negative is a positive. So putting it all together, let's see. 2 cosecant cubed x plus 2 cosecant x cotangent squared x. And there you go, right there. Cool, guys. Yay. All right, let's keep going. So this one wants the derivative evaluated at 2. I do not recommend using quotient rule. You can if you want, but anytime you have a constant in the top, guys, it's just easier to do chain rule. Just move everything in the bottom here to the top. So here we go. G of x, I haven't taken the derivative yet. Parenthesis 4x squared plus 5x to the power negative 1. And now I'm ready. G prime of x equals, bring the negative 1 to the front, negative 4x squared plus 5x to the power negative 2, and then your times derivative of the inside. That's your chain rule there. Times 8x plus 5. So rewriting it, g prime of x equals 8x plus 5 over, negative in the front, and over 4x squared plus 5x, close it with a square on it. Now I'm going to go ahead and plug a 2, guys. g prime of 2 equals negative 8 times 2 plus 5 over parenthesis 4 times 2 squared plus 5 times 2, and all that is squared, and you will get, there you go. Yay. Alright, let's keep going, guys. So on this one here, the way this works, you work your way from the inside out. So first, do this guy right there. So let's do that. So, d dx of x minus 5x squared equals 1 minus 10x. So now it says d dx of 3x times 1 minus 10x. You could do product rule if you want. I'm going to go ahead and distribute before I do this, like that. D dx of 3x minus 30x squared. And now I'm going to take the derivative. So the derivative of that is 3 minus 60x. And there it is. So this is, looks like it's chain rule, guys. So add x equals 0, given, and given. So they want, what do they want? dy dx. So remember that dy dx is equal to dy du times du dx. See how the du's cancel out and you just get dy dx? So that's what we're doing. So here we go. I need dy du. So I'm going to do that in blue. This guy, y equals u minus 2u to the negative 1. So dy du equals 1 plus negative 2 times negative 1 is a 2, u to the negative 2. So let's see, 1 plus 2 over u squared. So there's that guy. And then I'm going to do this one in green. So du dx is equal to 4x plus 1 to the third power times 1. So there it is. So I'm going to plug in x equals 0 into both, well, wherever there's an x, right? So I'm going to plug in x equals 0 in here. So let's see, if I do that, I get 0 plus 1, which is 1. 1 to the third is 1. 1 times 4 is 4. So du dx when x equals 0 is just 4. And let's see what it is up here. Let's see, right here. So u, when x is 0, is 1 to the 4th. So 1 to the 4th. So that means dy du when x is 0. Remember that we said that when x is 0, u is 1. That's what this means. When x is 0, u is 1. So, let's see. 1 plus 2 divided by 1 squared. So 1 plus 2 is 3. So finally, dy dx, which is equal to dy du. Dy du we said was 3 times du dx, and du dx we said was 4. So 3 times 4, 12. And there you go, guys. Hopefully that made sense. If it didn't, ask me again or rewind this. So here we go. Now we're getting interesting. It says g composite of f. I want the derivative of that at 7. So what that means is this. G composite of f. And I want the derivative of this guy at 7. That's all it means. So first let's take derivative. So derivative of the outside. Leave the inside alone. Times derivative of the inside. There. Now wherever you see an x, you're going to plug in 7. So here we go. G prime f of 7 times f prime of 7. I come in here. F of 7 is 8. G prime of 8 times f prime of 7. So f prime of 7 is 7. And g prime of 8 is 7. This should have made it a little more interesting, but that's fine. And there it is. Let's keep going. Express the derivative in terms of f prime. Alright, so this means this is considered the inside, guys. So we're going to do chain rule. So here we go. Derivative of the outside, f prime, leave the inside alone, 3x squared plus 2, times derivative of the inside. So derivative of the inside is 6x. So there it is. Maybe bring the 6x to the front. And there it is. Hold on, guys. I got to take a quick break because I got to release some stuffiness here. Come on, buddy. I'm back. I hope that it's recording. It is. Here we go. Let's continue. Question 9. Calculate the derivative of the given function. It looks pretty straightforward, guys. It looks like just good old-fashioned chain rule. So I'm going to rewrite this question. 4. Notice that it's a sign that is being cubed. So you're going to write it like this. Sine square root of x to the third power. So now when we take the derivative, f prime of x equals 4 times 3. 12, leave the inside alone, to the 2 times derivative of the inside. Hold on here, guys. Alright, derivative of the inside, and the derivative of sine is cosine. You still have the square root of x, times the derivative of that inside. Now, square root of x, side note, square root of x is the same thing as x to the half. So, 1/2 x to the negative half. There you go. And now we just got to fix it, guys. All this is being multiplied. Half of 12 is 6. So f prime of x is equal to 6 sine squared of square root of x, cosine of square root of x. And that x to the half goes down. So square root of x on the bottom. And you could probably do something with sine square root of x, cosine square root of x, but they decided not to do anything with it. And here it is. Alright, let's keep going. Find the equation of the tangent line for 4 tan x at x equals pi over 3. So for a tangent line, you need a point. So let's plug in 4 tan y equals 4 tan of pi over 3. So let's see, 4 and then tan of pi over 3, guys. So here comes the unit circle, not extreme, just a little bit. Let's see, 1/2 comma square root of 3 over 2. So tan is y over x, so it's going to be square root of 3 over 2 divided by half, so just square root of 3. So there's my point. My point is pi over 3, comma square root of 3. Cool? Alright, so now we need a slope. So how do we get the slope? Like this. We take a derivative. So derivative of tan is secant squared. And now if I want the value of that slope, I'm going to plug in pi over 3. 4 secant squared of pi over 3. Again, look at the unit circle at pi over 3. And secant is the reciprocal of cosine, so the reciprocal of half is 2. And I'm going to square that. 4 times 2 squared. So that becomes 16. 2 squared is 4. 4 times 4 is 16. So here's my equation. Y minus square root of 3 equals 16 parentheses x minus pi over 3. And I look for that. It's not, well, okay, sorry guys. I made a mistake, a small mistake. Look at this. It's 4 times square root of 3, so there's a 4 right there. 4 square root of 3, so there's a 4 right there. My bad, guys. My apologies. But yeah, everything else is good now. So that means my equation is 16x minus pi over 3, close it, plus 4 square root of 3. And we look for that, and there it is. Hopefully that didn't create any trouble, guys. I hope we're good. I don't know how I missed that. I mean, come on. I'm gonna blame the excuse on my sickness at the moment, but that's not an excuse. All right, here we go. Determine the values of x between 0 2 pi and 2 pi where the tangent lines are horizontal for this function here. So I'm going to take a derivative, and I'm going to equal it to 0. F prime of x equals the derivative of 10 sine x is 10 cosine x. And the derivative of 10 cosine x is a negative 10 sine x, but negative times a negative is a positive. So 10 sine x. I'm going to equal that to 0. I'm going to factor out a 10. And then I have cosine x plus sine x. And I still want that to be 0. So if you want to stop right here, guys, you can. Look, the only time that cosine x plus sine x is going to be 0 is if x and y are opposite of each other. And that happens there and there, quadrant 2 and quadrant 4. If you want to know what value that is 3 pi over 4, because the x value is a negative square root of 2 over 2, and the y is a positive square root of 2 over 2, so that's 3 pi over 4, guys. And the other value is, let's see, 7 pi over 4, because the x value is a positive square root of 2 over 2, and the y value is a negative square root of 2 over 2. Now, if you don't see these values, 3 pi over 4 and 7 pi over 4, what you can do, here's what you can do. You could say cosine x equals a negative sine x, and then I guess what you could do from there, you could say divide by cosine x, divide by cosine x, and you have 1 equals, and then sine over cosine is a negative tan. And I guess you move that negative here to the other side, and you can say, okay, where is tan x equal to negative 1? Well, tan x is equal to negative 1 at 3 pi over 4 and at 7 pi over 4. So that's another way you can do it, guys, but I hope that you can stop here at this one. But if not, no big deal, just keep going. I hope I helped. Let me know if there's anything I need to cover again, and I hope this helped, guys. All right, take it easy. Talk to you guys later. Bye.